Hello, today we are going to create a tactile search using Arc Welding PowerPac 1. Tactile searching is a method used in robotic applications to account for variations in part placement and part searching to find out what weldment is in the station. The wire and the gas cup are energized with a search voltage, the voltage being dependent on the manufacturer of the welder. Once a search is created, the open circuit voltage is applied, and once the wire or the gas cup touches the part, the circuit is closed and the part is found. Before the search is created, we need to modify the tool to make sure the hit points on the wire and the torch are where we want them to be. We want to choose a flat surface on the gas cup to use as well as a hit point on the wire. When choosing these points, there are decisions and preferences concerning the hit points on the tool. When choosing these points, there are decisions and preferences concerning hit points on the tool. If your gas cup is tapered on the end, like this one, a lot of people like to make their hit point on the non-tapered area to minimize variation in search corrections, since you're dealing with an unchanging dimension. Personally, if this taper is not too extreme, I will actually use the end of the tapered surface as my hit point. I do this because it limits the amount of reorientation of the tool between searching and welding. It can reduce cycle times. It can smooth out the air motions. In my experience, it can minimize error due to any variance in the TCP since I'm limiting reorientation. When using that tapered surface, I try to get the tapered surface parallel to the surface I'm searching. When choosing a nozzle search versus a wire search, there are pros and cons to each. Wire searching can be more precise and the orientation of the tool isn't as critical. However, if your search speeds are too fast, it's easier to flex or bend the wire during the searches, resulting in skewed search values. Furthermore, for best practices, it's recommended to perform an automated wire cut prior to searching, so that the wire is clean and at the correct dimension. This can add to cycle times as well. If you don't have a wire brake on your system, it's hard to do accurate wire searches because the wire retracts and extends to different lengths depending on the movement of the torch bundle. The gas nozzle is much more rigid and doesn't flex when it searches the surface. However, you have to orient the torch more to search part surfaces, and the searching surface isn't as sensitive at times. Depending on the system you have, the wire and gas cup could be energized at the same time, so you have to make sure the wire doesn't touch the part during the gas cup search, resulting in a false positive in your search and incorrect correction vectors. To define the hit point of our tool, we're going to open up the template tab under the Arc Welding tree. When we open up our tool properties and select the torch that we are using and double click on it, it opens up a wizard that shows us what our hit points are, our wire clearances, our contact tip dimensions, and our wire diameter. So as you can see here, we've already have the gas cup hit point selected in yellow, and that's the location I like to put it at. If you want to change where that's at, you just have to modify these X, Y, and Z locations. You can move it up or down the gas cup. Personally, I like to go to the very end of the gas cup and then back it off a few millimeters so that my search is on the flat surface and not hitting the tapered end of the edge of that gas cup. Now it says wire clearance for our gas cup search. Since we're using a stick out of 15 millimeters here, I I'm going to keep that value. The bottom of the gas cup, defined in brown, is just that. You define the bottom of your gas cup. Again, if you need to change that, you can. Gas cup clearance for wire search, it makes sure that your gas cup's not going to hit your part during that part search. It says to put it at 3 millimeters. I like to open it up a little bit just to give it a little more wiggle room, so I put it in for 5 millimeters. For the end of the contact tip, for a lot of purposes, can be the end of the gas cup. On a real system, depending on how the contact tip screws in, that can vary just a little bit, so I like to put it at a constant dimension, which would be right at the end of the gas cup. And then for our wire diameter, we're using 0.45 inch wire, so I converted that to millimeters and came up with 1.14 millimeters. Once you like what your tool properties are, you can hit OK. Once we've defined our tool, now it's time to start looking at how we want to create this search. For best programming purposes, you first create the weld in Robot Studio, then you follow by creating the search, and then you do the air moves to it. To make this process a little simpler, we're going to open up the part that we programmed earlier in creating a weld, just to cut down on time. So we've created the weld and air moves, and we're going to insert the search between them. So here's our part. Now we figure out how we want to search this part. We're going to assume that this square that we're welding can rotate in the XY, or can move in the X, Y, and Z directions slightly, and we need to account for searching on all surfaces. So we're going to do a three-dimensional search on it, which will be a series of one-dimensional searches tied together. So to create our search, we're going to create it right after our air instruction coming down. We're going to hit Create Search Instruction. So since we want to create a three-dimensional search, since we think the part's going to could have variance in X, Y, and Z direction between parts, we're going to go from a gas cup 1D to a search gas cup 3D template. And we're going to name this search a little different. After we renamed our search, then we're going to look at the search light here and choose how long we want that search to be. Right now it's at 30 millimeters and just over an inch. When you actually program that search length, when it actually goes into the real system and executes the search, it's actually going to double that distance. So when it searches within that 30 millimeter window, if it doesn't hit the part, it will continue past the program's hit point another 30 millimeters. So we're just going to assume that an inch is sufficient enough for the variation to account for the variation in the part. After we modified the search length, then we look at the search speed. On typical systems, I've found out that 10 millimeters per second works fairly well. The rule of thumb is the slower the search speed, the more accurate the search, and the more accurate the correction vectors. But the slower you go, the more cycle time you add to the part. And then after we modify the search speed, then we have two check boxes here to add a displacement, to turn the displacement off before the search, and then set the displacements afterwards. In this example, we're doing searching and welding in the same routine, and I've already created an instruction to turn off all the displacements, so I'm going to uncheck the box so we don't have to do that twice. But since we're welding right afterwards, we want to keep this displacement set afterwards after we've conducted that search. Once we do that, then we can actually go ahead and modify where we want to do these searches. When we look at creating these search vectors, we want to make sure, number one, that we search the most forgiving surface first, and number two, we also want to end up with our last search with the tool roughly being in the same orientation as it is for welding. So to do this three-dimensional search, the most forgiving surface we have right now is this one right here. So we're going to modify that search close to our start point. Our second search is going to be along the weld seam. And our final search is going to be along this surface. And you'll see the orientations and understand why I chose it in this order. Once our search vectors are created, we can then modify the targets as necessary. Like the pounce points during the arc welding applications, the pounce points follow the approach points. So if I modify this target's going to follow its orientation. So to modify these targets, we're going to select the search hit point, and we're going to hit modify target. From there, we can modify the position and rotate it about X, and then also modify the orientation about Y and Z about our hit point that was created. So we're going to actually, if we jump to the target right now, we can see that that search surface, it's hitting it at the right point, but it's not rotated to where this tapered surface is parallel to our searching surface, which is our hit point. So we want to actually modify that. Go ahead and hit apply, and then we'll jump to that target. So now, as you can see, our tapered surface is parallel to the searching surface. So now that we've modified the first point, as you can see, the approach point matched the orientation of the pounce point. Now we're going to look at the other vectors. I'm going to modify this one, the orientation of the gun. Then we're also going to rotate about X, 45 degrees. Hit apply, jump to that and see what it looks like. Again, we're going to want to make it parallel to what we had before. So that way our searching surface is parallel to our hit surface. We're going to do the same thing for our final search. As you can see in all of these, the wire isn't going to hit the bottom surface as we apply these searches, so that looks good. Make sure on these other ones. And we should be good to go. So we got the target modified how we think it could work. So let's see how these instructions play through. So a few things I'm going to change here. It looks like our orientation about 4 and 6 is a little tight. Singularity could be an issue, so we're going to smooth that out a little bit. So we'll put an intermediate move between our second and third searches. One thing that I need to mention is that when you're programming in Robot Studio on your searches, when you execute the search on the real system, once it reaches that hit point and finds your part, it's going to jump back to the pounce point in that search. This motion isn't recreated in Arc Welding 1, so if you want a realistic representation of the motion, you're going to have to add an error instruction after your search to make it bounce back. These targets can be edited out later, but for this real demonstration, we're going to add those just to look and make sure the motion looks okay. So it looks like we have a joint configuration problem on that first target. So it's between the first and second search. Smooth that out a little bit. So now that we got the motion smoothed out, now we can play through the entire instruction. One thing I forgot to mention is we have to modify our search instructions to make sure that the offsets are handled correctly. So we're going to hit modify instructions on the first search, and we're just going to look at all the searches and make sure they are doing what we want them to do. For our first search, two arguments we're going to be looking at is this pre-PDisp and this result function. So this is the result offset of the search, and this is what search offsets you need to add if there were prior searches done before this search. Since this is the first search in the instruction, we won't have to use that, but we do need a search result, and we'll keep it that name. So the first one is fine. For our second search, we're actually basing our search off the offset off the first search. So we want to make sure that that pre-displacement is set for the first search name, but instead, and they automatically populate that, but in the result they create a different search name for this search. We're actually going to keep it as the same name so that it constantly adds to the offsets in one stored argument, so that we have one displacement to turn on before welding. So basically what you're doing with each search is you're adding displacements to those correction vectors, and then the final result has all the correction vectors added into it. So for that, we've modified the second one. We're going to hit apply, and then for the third one we're going to do the same thing. First off, we need to make sure our pre-displacement and our results are the same name. We're going to hit apply on that. And then we can close that and make sure everything is how it needs to be. So no pre-displacement on that one. There's one on that one with the same name. And same for the third search, so we should be good to go. Now that we've modified that instruction, now we're ready to save out our XML file. Thank you guys. Have a great day.